Welcome to The Explainer, where we break down big topics. Today, we are diving into the modern standard for Java testing, JUnit 5.
For any developer, this is the million-dollar question, right? It's not enough to just write code. We have to prove that it's reliable, that it's robust, and that it does exactly what we think it does.
And for modern Java applications, the answer is a really powerful testing framework called JUnit 5. It's the go-to tool in the Java ecosystem for a reason. All right, let's get into it. So, here's the plan. We'll start with what JUnit 5 actually is. Then we'll peek under the hood at its architecture. After that, we'll get into the core tools you'll use every day, check out some really powerful advanced features, and then wrap it all up with how to run your tests and the key things to remember. Okay, so first things first, what is JUnit 5? Well, at its heart, it's the newest version of the most popular testing framework for Java, period. It brings a lot more features, a ton more flexibility, and just a completely modern design compared to the older versions like JUnit 4. Now, what's really interesting is how it's built. See, JUnit 5 isn't just one single giant piece of code. It's actually made of 3 separate modules that all work together, and that's the secret to its flexibility. The best way to think about it is like a theater. The JUnit platform, that's the stage itself. It's the foundation that lets you launch and run tests on the JVM. Then you have JUnit Jupyter. That's the engine for writing all your brand new modern tests with all the latest goodies. And finally, there's JUnit Vintage. Think of this as a special engine that lets you run all your old tests, the ones written in JUnit 3 or 4. It means nothing gets left behind, and you can upgrade at your own pace. All right, let's get into the stuff you'll be using constantly. We're going to start with annotations, which are basically just special labels you pop into your code to tell JUnit what a specific piece of code is supposed to do. So here's your basic toolkit. @test is the big one, obviously. It's what turns a normal method into a test method. Then you've got helpful things like @displayname to make your test reports easier to read. But the real magic, the real control, comes from the before and after annotations. They let you manage the setup and cleanup for your tests with pinpoint precision. Now, understanding the order these run in, what we call the test lifecycle, is absolutely crucial. First up, any method you mark with @before all runs exactly once, right at the very beginning. This is perfect for those heavy one-time setup jobs, like spinning up a database connection. Then, for every single test method you have, this 3-step cycle repeats over and over. First, @before each runs to set things up. Then, the @test itself runs. And finally, @after each runs to clean up. This whole process guarantees that every test starts with a clean slate, totally isolated from the others. And after all those test cycles are finished, the @afterAll method runs one last time at the very end to tear down whatever you set up in the beginning. Getting this flow down is totally essential for writing solid tests. Okay, but how do you actually check if your code is doing the right thing inside a test? Well, that's where assertions come in. They are the absolute heart of every single test. They're the little checks that decide if your test passes or if it fails. JUnit Jupyter gives you a whole bunch of these right out of the box. Your bread and butter is going to be assert equals, which just checks if the result your code gave is what you expected. You've also got assert true and assert false for simple true-false checks, and assert not null to make sure your code didn't just give you, well, nothing. But listen, JUnit 5 is so much more than just the basics. It has some incredibly powerful features for when you're dealing with more complex situations. And this is where it really starts to pull away from the pack. For example, parameterized tests are an absolute game changer. Imagine you need to test one function with, say, 10 different inputs. The old way, you'd probably write 10 nearly identical tests. With this, you write one test method, and then you just feed it all 10 inputs. JUnit takes care of running that same test 10 times, once for each input. It saves you a massive amount of boilerplate code. And if you think that's cool, there's something even more flexible: dynamic tests. Now, these aren't tests that you write out ahead of time. They are actually created on the fly while your tests are already running. Yep, you heard that right. Using an annotation called @testFactory, you can write a method that literally manufactures test cases while the program is executing. This is unbelievably powerful for situations where your test cases depend on some complex logic, or maybe they come from an external file or a database that you only know about at runtime. Okay, so you've written your brilliant tests using all these annotations, assertions, and maybe even some crazy dynamic tests. Now what? How do you actually run them? And what's the big picture here? Well, the good news is running tests is seamless.
If you're using a modern IDE like IntelliJ or Eclipse, support is built right in. You can usually just click a button to run them. It also works perfectly with build tools like Maven and Gradle, so you can easily make testing part of your automated workflow. And of course, you can run them from the command line, which is great for CI/CD pipelines.
So when you boil it all down, JUnit 5 is a huge leap forward. It's built for modern Java, its modular design makes it incredibly flexible. It has really powerful features that solve real-world problems, and because it's backward compatible, you can start using it today without having to throw away all your old tests.
Look, at the end of the day, it's more than just a tool. It's a modern way of thinking about quality that actually keeps up with how we build software today. It makes sure that as your code evolves and gets more complex, your ability to actually trust that code evolves right along with it. Thanks for watching.